This is Mr. Martin. This is the video for section 6.2 for Pre-Calculus Honors. This is day 2 of Law of Cosines. And before we get into some other problems, let's take a look at some review of area of a triangle that we have so far. So the area of a triangle that we have so far, we had those formulas, but really the way I like to think about it is in terms of words. So state the area formula of a triangle in words, and we want to use the sine one. So basically, the area is equal to half the product of any two sides of a triangle and the sine of the included, notice I have this in capitals because that's important, included angle. Okay, so we have one possibility here. I have sides A and B, and the included angle would be C. So really, you're always going to have two sides, and then whatever those two sides are, you'll have the third angle in that triangle. So let's take a look at a quick derivation of that formula. So I'm going to label my triangle ABC, and I'm going to let this be the height. Then this would be side B, this would be side C, and this would be side A. Alright, so as always, if you have questions, make sure you pause the video and write those down. And if you think I made any mistakes, also pause the video and write down what you think my mistake is, and let me know when you see me in class. Alright, so we're going to use this picture and derive the formula. And we know that the area of a triangle is normally 1/2 times the base times the height. So my base here is A, and my height here is H. So what I'm going to do is I'm going to use this right triangle here to find the height. Alright, so the height is H, and then I'm going to use B as the hypotenuse, so that would be the sine function. So I know that the sine of angle C is going to be H over B. And then if I solve this for H, I get that H is equal to B sine C. Alright, so now this becomes 1/2. The base here was A, and the height was B sine C. And there you have it. Okay, so there's the derivation of that. And here's another quick example. I'm not going to take the time to work out the example, but if you want to pause the video and work out the example, you should end up with 12 units squared for your answer. So if you want to work that out, and again, if you have questions, make sure you ask me. I should have the worked out solution with me in class. And as far as units, even though I'm going to include them in the video here, if they're not given in the problem, you don't have to include them in the answer. But if they are included in the problem, you should include them in the answer. Alright, so here's another formula for the area of a triangle if you know the three sides of the triangle. And it's called Heron's formula, and you may have seen it before, but if you haven't, the area is going to be equal to the square root of s times s minus a times s minus b times s minus c, where this s is the semi-perimeter, so it's half, semi meaning half the perimeter. So if you're given three sides and you want to use this formula, the first thing that you're going to want to do is figure out the semi-perimeter, and then you just substitute everything into the formula, making sure you're careful plugging everything in. So let's take a look at a quick example. So first, the semi-perimeter, that's going to be half of the perimeter, so that's 4 plus 5 plus 7. and that should give us 8. And then we can find the area by substituting everything in. So I'm going to have the square root of 8 times 8 minus 4 times 8 minus 5 times 8 minus 7. So basically we just subtract the length of each of the three sides from the semi-perimeter. Again, be careful when you plug this into your calculator, and you may want to just double check that your calculation will give you 9.798 units squared. Alright, so the rest of the video is going to be a bunch of examples. So really what I would recommend here is that you go through these examples on your own and see what you can do. For some of these you're going to have to do a little bit more work because you won't have all the information that you need to just plug right into the formula. For example, C and D, you're going to need a little bit more information than what's given. For A and B, you're simply substituting into the formulas. And then the problems on the last page are a little bit more difficult. And what I'm going to do is I'm going to write the answers to each of these next to the question, and you can go through and check as you go. And again, if you get a different answer than me and you want to double check with me, make sure you ask me in class. So again, if you don't want to see the answers right away, just hit pause and work through those. Otherwise, I'm going to give the answers for these. So for A, we've got 0.75 units squared. And for B, I got 19.900 units squared. Those two were just substitute in and solve. For part C, you're going to have to first find an angle and then find another side before you can use our 1/2 AB sine C, or whichever formula is appropriate. And I got 0.922 units squared. And then part D is the same thing. You have to find an angle and another side. And I got 2.275 units squared. And then on the last page, just a hint for part E, you may want to draw a little sketch and then use the distance formula to find the lengths of the sides. And for this one, I did not change any of the lengths of the sides into decimals. I used whatever they came out as. So, and I labeled this side, this point A, and this point B, and this point C. So for example, for AC, I got the square root of 10, and I just used the square root of 10 in all my calculations. And for this one, I got 6.5 units squared. So you want to get something close to that if you're going to use decimal approximations. And for part F, not too bad if you follow the hint there. For this one, I got 7,690.525 units squared. And for part G, again, this one involves a little bit of work. You're going to be working with this bottom triangle first. I would recommend finding this side here. And then you're going to work with this triangle in the back there to find the height. And for the volume, I ended up with 270.149 units squared. So what I'll do also is have these problems and notes on my website. I'll put that on the flipped video resources page right underneath where the link for this video is. So you can go ahead and look at the solutions for those and check your work against my work and let me know if you have any questions. So that's the end of this video, and we will see you next time.